Okay, now we're going to be looking at equations that have single variables with fractions. I have my C here, with fractions. These can be a little bit difficult because they use a different property called the multiplication property of equality, and usually we struggle a little bit with fractions, even I do. So this is an example of a single variable equation that has fractions. This is 1/10 n. So that means if I had an n here, let's say this is 1n here, I would divide it into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. And when I say 1/10 n, I'm only talking about this 1/10 of the n. Okay? So think about it conceptually, that's what we're talking about. Now, when I say 1/10 n, it's also 1/10 times n. So sometimes you'll see 1/10 n represented as n over 10. It's the same thing, because if I take n and I put it in fraction form, anything that is an integer is the number or the variable over itself, so it'd be n over 1. N is the same thing as saying n over 1. So if I multiply this across, I get 1 times n, which gives me n, 10 times 1, which gives me 10. So that's why if I'm looking at n over 10, it's the exact same thing as 1/10 n. Okay? So next, I'm going to start looking at it now that we've established that. So with 1/10 n equals 9 minus 1/5 n. I'm going to look and see, do I have distributive property? I don't. And then I'm going to combine like terms. So first I'm going to identify my terms. I have one variable term on this side. There's no other term, so I'm going to leave that alone. I have one constant term on that side. I'm going to leave that there. And I have one variable term on this side. Now when I look at this expression, there's nothing for me to combine it with. So I'm just going to leave that as it is. If I look on this side, I also have nothing to combine it with. So I also leave that like that. So next I'm going to move on to isolating my variable. I'll bring this down just to show that I did look and see if there were terms to combine, but there weren't. 9 minus 1/5 n. Now the reason that this is so difficult is because we see fractions and we get scared. Now you have to have some number sense, but when I see fractions and I get scared, I'm going to want to turn it into an integer. So I want you to think, if I need to turn this into an integer, what number can I multiply 1/10 by in order to make it an integer? Let's look at that visually on the side. Remember I had I have 10 parts here. When I talk about 1/10, I'm talking about one of these. So if I have one of these, how many of those do I need in order to make 1? I need 10 of them. So I need to multiply it by 10, and then when I multiply it by 10, 10 times 1, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this would get me to 1. So what I'm going to do, and you need to always remember, you have to do it to everything. So if I do it to one thing, I have to do it to everything. So I'm going to put a parentheses around this. And to try to make it an integer, I'm going to multiply it by 10. Now I'm going to put 10 as a fraction because it's a little bit easier to think of when you're multiplying if you put it as a fraction. And 10 as a fraction is 10 over 1. So now when I multiply across, I get 10 over 10. 10 times 1 is 10 over 10 times 1 is 10. And then I have my n over here. Okay? 10 divided by 10 gives me 1. So I'm just going to make this n. So now you can see when I multiply it by 10 that it becomes an integer, it becomes 1. So I'm going to set that equal. Whatever I do to this side, I have to do to that side. That's why we call it the multiplication property of equality. So I'm going to take this entire amount. Remember, you must do the entire amount, and I'm going to multiply it by 10. That means that I have distributive property now. So I'm going to distribute this to both terms. That would leave me with 9 times 10 plus a negative 1/5 times 10. Okay, now when I come down, I don't have anything to do on this side, but I want to continue this problem by simplifying this. So I get 9 times 10, which gives me 90. And then 1/5 times 10. If I go over here and I do that multiplication, 1/5 times 10. Oh, and I forgot to put my n here. This is a big problem, but a lot of people struggle with. So I've got to put not just 1/5, but 1/5 n times 10. So 1/5 times 10, and I get 10 over 5. Remember, I have to multiply the coefficients. And it's negative, so it's negative 10 over 5, negative 1/5. So I get 10 over 5, which gives me 2. So now I have negative 2, and remember it's a variable term, so you bring n. Now if you look what I did, I no longer have any fractions. So that's the point of taking the number and making it an integer by multiplying it by a whole number. So we have n equals 90 minus 2n. Now we're just going to finish the problem like we normally would. We're going to go to isolating the variable, in which case we need to add 2n on this side and do the same thing on this side because it is called the addition property of equality. So when I do it on this side, I get 0 for negative 2n plus 2n. There's nothing to subtract my 90 from. And then I get n plus 2n, which gives me 3n. Now I've done all my addition and subtraction, so I can do my division. I divide 3n by 3. 3n divided by 3 gives me n. Oops, move it up. 3n divided by 3 gives me n. Then I divide 90 by 3 and I get, not 60, I get 30. So now I've solved and I've got n equals 30. One thing I want to go back to is the original problem. So I'm going to erase this and we're going to go back to the original problem and look at why I multiplied by 10. Okay, now I multiplied by 10 up here because I look at this fraction and I always am going to multiply by the reciprocal of the fraction. So that means if I have 1/10 n, I'm going to multiply it by 10 to get to 1n. If I had 2/3 n, I would need to multiply it by 3/2 n. And I would do 3 times 2, which gives me 6, over 3 times 2, which gives me 6n. And again, I get to 1n. So I want you to try this with the next two. If I get 4/5 n, if I see that, what do I need to multiply it by? You need to multiply it by 5/4 to get 20. 5 times 4 is 20. 4 times 5 is 20. N. And again, I end up with 1n. Now I want to look at it in a different way. If I see that I have n over 6, what is that equivalent to? We can remember that it's equivalent to 1/6 n, because if I take this n and I put it in terms of a fraction, it would be n over 1, which gives me n over 6. So now that I have this, know that it's 1/6 then, what do you think I should multiply it by? Put that on your paper. Okay, you're going to multiply it by 6 because the reciprocal of 1/6 is 6. So I'll do it as 6 over 1 so we can see. So 6 times n is going to give me 6n. 1 times 6 is going to give me 6. And then when I see this, I see that 6 divided by 6 gives me 1. So again, I end up with n. Now I want you to try the problems that are on this sheet so that you can practice and ask if you have any questions.